So, one slide on chemical digestion, and then I'm gonna move into a drawing for the next. Let me see how many slides we got here. Next, 82 to 89. So I'm going to cover slides 82, well, on my thing, 82 through 89. So the next 7 slides in a drawing. Okay. So chemical digestion. So we've talked about this point how so juices are going to be secreted. We've talked about the movements. We've talked about how everything gets there. And so now what we're going to talk about is probably one of the more important things is how do we break down that food stuff into smaller particles? So digestion is a catabolic process where we take large macromolecules, so large, for example, proteins or carbohydrates or starches, and we break them down into their simpler building blocks, so they're monomers. And we break them down to their simple building blocks so that we have um, molecules that are small enough to be then absorbed. And in order to carry out this digestive process, we need to have a number of enzymes. And these enzymes will either be intrinsic and accessory gland enzymes, so they'll either come from within the digestive system or come from glands outside the digestive system. So if you think about the pancreas, right? Pancreas is an accessory organ, but we have enzymes that come from the pancreas that are really important for breaking down that food stuff. And we have something called hydrolysis, which is basically water is added to break the bonds. Okay, so what we're going to do, like I said, we're going to take these next 7 slides and we're going to break them down into a drawing. So this is the chemical digestion process. Okay, and what we're going to do is the following. We have 3 molecules. We have our carbohydrates. Okay, we have our proteins. Okay, we have our lipids, and the last is we have our nucleic acids. Okay, so if nothing else, we know that when we're talking about carbohydrates, we're talking about oligosaccharides. Okay, and these are things like starches. Okay, when we talk about proteins, we're actually talking about proteins. When we're talking about lipids, we're talking about triglycerides. Okay, and when we're talking about nucleic acids, we're actually talking about nucleic acids. Okay, so these are our complex macromolecules that we see here, right? Oligosaccharides, proteins, triglycerides, and nucleic acids. But these need to be broken down into their basic building blocks. When we talk about basic building blocks, we're talking about things such as for our oligosaccharides, right? We're going to break these down into monosaccharides, such as galactose, glucose, and fructose. Right? These are our basic building blocks. Okay? And you can see this big white space that I'm leaving here, and I'm leaving it there for a reason, and we're going to see here in a minute. Okay? Our proteins are broken down into amino acids. Okay? Our lipids are broken down into 2 things. If you remember, hopefully you guys all remember, monoglyceride and fatty acids. Okay, and the last thing that gets broken down, or not the last thing necessarily in order, but we also have our nucleic acids. And our nucleic acids, when we break these down, give us a pentose sugar. Okay, we get nucleotides, and we got phosphate ions. Okay, so those are our end results of digestion, right? So these are our basic building blocks, and we're going to basically after we get done with this drawing, take this information, these guys over here, which are our these are our monomers, right? And we're going to take these monitors into absorption here in a few minutes. Okay? Okay. But the question becomes, how do these carbohydrates get broken down, these oligosaccharides get broken down into these monosaccharides? And now there's a few places that this is going to happen. Okay? The first place this is going to happen is our salivary amylase. Salivary amylase. I spelled that wrong. Amylase. Okay? So, as that carbohydrate enters our mouth, we release salivary amylase, and salivary amylase will start initiating the process of carbohydrate breakdown. The next place that we have enzymes that are going to act on these starches are our pancreatic amylases. Okay? And then the last place that basically acts upon here are our brush border enzymes. Okay, so we have 3 different areas within the digestive system that are going to help in the initiation, the breakdown of that oligosaccharide. Key thing to take away from here, anytime you see an amylase, anytime you see the word amylase, that tells us that that is going to break down carbohydrates, okay, or oligosaccharides. Excuse me. Okay, so proteins. The first thing that's going to act on proteins is in our stomach. So we have pepsin plus HCl. Okay. The second. Anybody got a guess? Our pancreatic. The pancreatic enzymes. Okay. And this is going to be a classic one here is going to be your trypsin. Okay. And then the last place, and I'm just going to abbreviate this brush border enzymes as BBE. Okay. Our brush border enzymes will secrete enzymes to break down those amino acids. If you go back, I won't ask you guys specifically the exact enzymes involved, at least in protein, just because their names aren't super easy. I do want you to know trypsin and that trypsin's involved in that process. But in terms of the brush border enzymes, don't really worry about those. Just know that they're going to come from the brush border cells of the small intestines. Okay? So, lipids. And I might actually jump onto another slide just to show you the lipids if I can't fit it in here. Okay? So, lipids. First place we're going to get it is lingual lipase. Okay, lingual is mouth, right? So, lingual lipase will initiate the breakdown, or at least start the breakdown. We have our next place is our gastric lipases. Okay, so those are going to come from our stomachs. We're going to get emulsification with bile. So we'll get bile. Now don't forget, bile is not an enzyme. Okay, bile is going to create those little micelles around the little fat particle, right? So it takes a large fat molecule and breaks them down into little teeny structures called micelles. Okay, and then the last place of digestion is our pancreatic lipases. Okay, and that creates our monosaccharides and our fatty acids. Now again, just like our carbohydrates have a common theme, our lipids have a common theme, and that is that they are broken down by lipases. Okay, so lipases are super key in getting us to our monoglycerides and our fatty acids. Don't forget, however, though, this bile is absolutely not necessarily, I won't say essential, because you can live, well, if you lost your liver and your gallbladder, you probably would not be able to break down triglycerides. But the fact that we have um, even if we lose our gallbladder, we still have the liver basically emptying some bile into the small intestine. Okay, I'm gonna pause us just because the yard's going crazy. Hold on really quick. Okay, hopefully you guys will be able to hear me a little bit better. They had stopped and now they're gonna start up again. So anyways, the last is our nucleic acids. And nucleic acids are fairly easy in that they're only going to be acted upon by our pancreatic enzymes and brush border enzymes, right, to get us our pentose and our things that we need here. Okay, so this is chemical digestion. I don't know, for me, I like to see this all on one page and it makes more sense. Your book has a very similar kind of chart for all of these. I kind of just sum it up in this one slide. So again, make sure you guys understand the macromolecule, the basic monomers, and the basic enzymes that are going to basically be carrying out the digestive process of those molecules. Okay.